Hello everybody, my name is Rojanex, and today I'm going to be showing you how to set up a Node.js C++ add-on inside of Visual Studio. To begin, we're going to need to get Node's source code because we need the .lib file that's created when you compile Node.js, and you can get the source code using get from the GitHub repository. I've already cloned it here, and inside of the folder, you're going to get this vcbuild.bat. Now that's the file that's going to actually build it. You don't need to open it up in Visual Studio or anything to build it. When you build Node.js, you're going to want to use the no sign option because you don't have a certificate to sign the executable. It'll just create an error if you try and do it without no sign. Also, when you build it, it will by default build a release 32-bit configuration of Node.js. In order to build debug, you type in debug. You can even type in release to specify release, and in order to get 64-bit, you type in x64. Now, when you build Node.js, it's going to put the binary and the lib files inside of debug and release right here inside of the project directory. Those of you familiar with Visual Studio will be familiar with the x64 folder that usually has the release and debug versions of x64-bit. Well, the Node.js project is not set up to do that currently. So what I have done is I built the debug and the released versions of 64-bit and then created a 64-bit folder and moved them in there, then rebuilt the Node.js release and debug configurations without the x64-bit parameter and had just those two versions here. So we have the 32-bit versions over here and the 64-bit version inside of our 64-bit folder. It will take quite a while to build Node.js, especially if you want to build all four of those configurations, which I highly recommend. So I'll give you some time to do that and just come back to the video when you're ready and when you've done all of that. So I'm assuming that you either have built all of the configurations or you just want to continue watching the tutorial and we'll do it at a later point in time. So now it's actually, before we open up Visual Studio, we want to have really quick and easy access to this folder. So what we need to do is set an environment variable, which we use the setx command. And if you want to make it a machine variable or like a system variable as opposed to just a user variable, you use the /m option. I'm going to name this variable node home. The way that this node home variable works is you need to give it the current directory, which you can get using %cd%, and that will get the current directory that that your terminal's in. Now, if I try and say set and if I try and find this, you're only going to see this node root. The node home variable that we created, we can't see because we need to reopen up our terminal in order to see it. Now let's see if we set grep node. Now we have this node home and node root. Now I can easily get to my product directory using node home or node root. Now we can open up Visual Studio. Now that we have that environment variable set, it's going to be really easy for us to create the project like we want to create. One of the things that I want to show you how to do, and if I can get to the project, I'll be able to show you it, is we're going to be able to have a node add-on option here inside of Visual Studio, which will allow us to quickly make a Node.js project without having to configure everything like we're going to go through this first time. So we're going to call this node add-on and go ahead and create it. Oh, and just to be clear, what I did is I created a blank project, an empty project. we don't want any other files inside of here, so make sure that you selected that empty project when you created your Node add-on. Now, I like to have a specific way that my files are set up. I'm going to add in first here a main.h file. And I'm going to browse real quick. I'm going to create two directories. I'm going to create an include and a source directory. And we'll put our header file inside of the include and all of our source inside of the src directory. I'm going to call this main.h. And let's go ahead and also create that main.cpp as well. And make sure we choose the source folder instead of the include folder. Okay, what this does, I clicked on show all files, so I can easily, if I right click on this folder here and I go to add new item, it's actually going to create the new item inside of that folder. You'll see this include down here, even though the last folder we used was actually the source folder, which I find it's nice to be able to create my header files and source files in those directories. So if you just click this button, this show all files button. Alright, now we need to actually configure the project a bit first. We want to make sure that we select all configurations, and what we're going to do is inside of the general option, we need to first make this a .dll, because a Node.js C++ add-on is actually just a dynamically linked library that has the extension .node. So we're going to name it .node as well, because that's what Node's going to be looking for, just so we don't have to rename it after the fact. And we only have a Win32 configuration. We'll actually make that 64-bit configuration based off this 32 one after we're done here. So we need to also, at this point, tell Visual Studio where our Node include directories are. Now, if we're going to pop back over to the terminal and look at all the different files here, we'll notice a source file. Just go inside of that source file. This folder actually has all of the header files and the implementation files, which is kind of nice for us, which means we just need that src. So inside of here, we can get our project variables. If we click on macros, you'll be able to, unfortunately you won't be able to double click on them and add them in this folder, but you can search for them, and we'll see we have those node home and node root. I'm going to set this up as node root and then src. This is the additional include directory, so it'll add in all of our different include files into this current directory here. We also need to set up our additional library directories up here so we can actually link against Node.js's .lib file. So if you type in configuration, you'll notice configuration says debug. That's going to be a really easy shortcut for us to add in all these different configuration types, so we don't have to type them in a million times each. So we're going to type in our node root or node home folder, and then we're going to type in our configuration. And that just makes it so we don't have to go into debug and release and put debug and release in there for each individual application. I'm going to apply it, but we're going to do some more configuration inside of here. Inside of the linker, we need to go to the additional dependencies of the input, and we're going to add in node.lib. Now there are a couple other things that we're probably going to need to do in here, but for now we're just going to save our preferences and start creating our main file. Let's go over to Node's website because they have some awesome examples of how to create a Node.js add-on. Now inside of the API, if you go to add-ons, I have it API/addons.html bookmarked, so it's easy for me to get to. I'm going to scroll down and we'll type in C++, and we'll see this wrapping C++ objects. Now let me make this a little bit bigger for you. To begin, we have our main add-on, and this is the source we're going to copy into our .cpp file. I mean, we might not even need to use an implementation file, but it's just a standard that used to creating. We'll go ahead and include it. Now, you'll notice that it can't find main.h. There is an additional include directory that we need to add. Make sure we select all configurations up here and go to C++, General, and add in our project directory / include. And that's going to make sure it can find its own include files. Now, we have not created my object.h. We'll comment out my object.h and my object down here. We're getting a couple of errors. Now, the reason that is, we also need to add in the dependencies for v8 inside of our directories. We're going to go back in here and make sure we have all configurations selected. And we're going to go node root, and then let's just pop over real quick into the directory, and we'll see this deps folder. And inside of deps, we'll see v8 and uv. We're going to want to include both of those, but let's pop into v8 real quick so we can check out its structure. And inside of v8, we see we have that typical include folder. So we're going to add in v8 or deps/v8/include. And we're also going to add UV, and UV is Node.js's event loop. So that will give us access to the event loop includes. And with any luck, it finds v8 now, and now we can, in theory, compile this, and we shouldn't have any errors. Alright, so it looks like it worked just fine for us. Now, we're getting pretty close to being able to test our application, but we also want to be able to wrap a Node.js object. But before we go into wrapping an object, I just want to explain really quickly what this file here is doing. So we have this initAll function that takes a v8 handle as an object, and it's called exports. You should be familiar with this object inside of Node.js. Whenever you create a module and you do module.exports equals, this is that exports object that we are normally attaching stuff to and setting stuff to. This initAll function is going to be passed into Node.js as the main code to run inside of the add-on, and it'll be attaching all of the objects to the exports object to allow the JavaScript to access those objects. The module name must be the same name as the executable file. We see right now it's just addon. So we're going to name that node addon. And we're going to have to rename this if we create another file from our project to whatever the project name is. We could also set up inside of our general configuration this target name to be the name of our add-on and make it the same in our source, but we're just going to manually configure that for now. You'll notice another thing up here, this building node extension. This define tells the compiler, well, there's different source files for Node.js, and it lets it know that when we're using those header files, it's that we're actually building the Node.js extension. It'll include certain files for it. Now we want this to be enabled all the time without having it to punch it into all of our files. If we actually go into our settings for all of our configurations and go to C++ and go to preprocessor, we'll be able to have additional preprocessor definitions. We're going to paste in our building node extension in there, and that will be defined in all of our files now. We can see that by if we say if def building node extension and if, and you'll notice that this code is not grayed out, which means it's actually enabled. We don't really need this code. I'll delete it. Let's go back over to the example on the website. Now this is the myObject.h header. We're going to create that .h file as a basis object to reference whenever we create a new project, in case we forget how Node.js header files work. We'll call this myObject.h. So there is a couple of different things that we're doing inside of this object that I want to talk about. So this object wrap function is a function that Node exposes to help us easily wrap our C++ objects. We're going to extend all of our objects from that so that Node.js will be able to wrap and unwrap the objects as needed. The init function is what we're going to pass initially when we export our module when it's first created. It's going to bind the different functions or objects to the exports variable. If we go back into our main.c++ file, we'll have that init exports. We can actually now uncomment these lines and it's not going to complain because it'll be able to find that myObject. So we're going to pass the exports object over here to myObject and let myObject attach itself to the exports variable. We have in here explicit private constructor for myObject, which takes in a double, and this is specific to this basic test object here, and that value is going to set value inside of this object. This object doesn't really do anything cool, but it'll give you a basic template on how to wrap C++ objects for Node.js. Down here we have this new function here. Now this is a static V8 handle that returns a value and takes in these arguments over here. This new operator here is actually going to be in JavaScript when you say var object equals new object. This is the operator or the constructor that's actually going to create the object. So you can think of this new operator down here as the JavaScript constructor and this constructor as the C++ constructor. Now we also have this extra constructor function, this persistent one down here, and we'll talk about that once we get into the C++ code. Well, notice this other function in here, this +1, and this +1 function is just a function attached to the object that's going to increment a value. Now you notice that this function is also static because it needs to be accessible by JavaScript. So we'll talk about how we actually work with JavaScript when we need to have these static objects or these static functions to actually reference member variables of our real object. Let's go back over to Node.js's website and copy in the implementation file create our new myObject.cpp file. And we go up to the top. We can actually take off this building node extension because of our global define there. Alright, to begin, we're going to declare that persistent function at the top of here because it is going to be kind of like our singleton to construct our object. And we're going to have our object take in our value and set our internal value to that value initially. We don't need to do any destructing because we don't use the new keyword inside of this object. And we'll move on to the init function. Now, if you remember, this is a function that main.cpp calls and sends it the exports object. So this is where the object is actually going to attach its own function prototype to the exports object so we can create new objects. First, we create a local function template from the new function down here. We're going to set that template's class name to myObject or whatever you want the name of your object to be. The internal field count tells tells V8 how many objects this constructor or this function creates, and we're only going to be creating one object from this function. After that, we're going to attach all of our functions that we want, specifically our +1 function, to our object. So we add the +1 as a string in here, and then we attach in the function template from the +1 function, and we use the get function to bind this +1 to that function. Now we can create our constructor, and we set our constructor equal to the template.get function, and this is persistent. Now, if you want to know what that means, just go over to Google's website for V8 and read through their documentation. It seems really daunting and seems really long, but it's pretty simple once you actually start reading through it. Everything is very logical and named for certain reasons. It's very easy to follow once you just buckle down and start reading it. So we're going to get the function for our template, which is going to be that new function that we're going to be creating. And then finally, we're going to export the symbol myObject to the constructor, or as a constructor to the object. So myObject is going to call this constructor, which we know is going to call this new function down here. And the name of the object is myObject, and also the class name is myObject. So the new function, the function that's actually going to be creating our object, first we need to get our handle scope, because we're going to be returning these handle values here from V8. We need to have a handle scope. Now the first thing we're going to do is we're going to, inside our arguments, see if this is a construct call. So basically, this is if the object was created using the new keyword. Otherwise, we're going to jump down here. We're going to look at the else first. So if we do not use a new keyword, if we just call the function myObject, what we want to do, as the comment says, is turn it into a constructor call. So we're going to create a variable argc, set it equal to 1. We create our argv and pass in our argc. in there, and then we're going to forward any of these arguments, the first argument, into our arguments in there, and we're going to close the scope calling the constructor new instance, which will instance an object, which basically will recall this function as a constructor call. So now that we've converted this regular one into a new one, so all of our calls to this function will always be invoked with the new operator, we can look at what it does. So it creates a value from the first argument. First it checks if it's undefined, and if it is, we're going to use 0, otherwise we're going to get the number value of that first argument. Next, we're going to create our object. So this object is going to be that object, the C++ mirrored copy of the JavaScript object. And we're going to pass in the value that we've created, either 0 or the number value that we got. We're going to call the wrap function on the current argument to wrap args.this. So that's going to be wrapping our argument there, and we're going to return that as our value. So this is actually going to create our new C++ object and give it to Node.js in a way that Node can keep track of it using that wrap function. Now we can take a look at the +1 function down here, which can be called on the object. It takes in our arguments as they do, and it returns the value, handle value in there. We get our scope. Now the first thing we do is we create a pointer to my object, and we're going to use the unwrap function of args.this. If you remember, we wrapped args.this. So now that we have that, we're basically telling Node.js up here the scope of this is going to be wrapped in this object, and then we need to unwrap that object from the scope of this there. We can increment value by 1, and here we return whatever the value of the object is as a number. So it's pretty simple. If we build this, it should build. Now we want to be able to test this. What we're about to do, this isn't going to actually save when we create our project, but this is just to test that our project works before we save it as an option inside of Visual Studio. The command we want to do, if we type in node home, or root rather, and then we type in our configuration, and then we type in node.exe, this will run our node program. And if we change our working directory to our output directory, this will actually allow us to be able to run a Node.js console and include our add-on right from Visual Studio. If we click the run button, it's going to run up a new instance of Node.js in a little console window. Alright, now all the symbols are loaded. We're going to pop back in here, and on the constructor call, let's put a breakpoint on that if. Now you notice that the breakpoint is not filled, and if we mouse over, it says no symbols have been loaded for this document. Well, that's because we haven't actually loaded in our extension, our node add-on extension. To do that, if we can say var add-on equals new or require, and if we do / for the current working directory and type in node add-on, we now have our add-on, and you'll see that that breakpoint is now defined because this dill has been loaded and Visual Studio had the symbols for it. We can now break every time we create a new object. We say add-on and we use the completion, we can see we have that my object. We'll create var o1 equals new addon dot my object, and we see that we're taking to Visual Studio and we're break in here. So this is construct call is going to, because we use a new keyword, return true, so we can continue. Let's step out of this function. Step over, and now we're inside of here. We'll go ahead and continue it, and now we have our new object. So if we do o1 dot plus 1, since we did not pass in a value, we're going to get 1. We'll do it again, we'll get 2, 3. Now if we use the if we create an object without using that, we'll go in here. If we step over, we see we're in there. If we press continue, it's going to take us right back here because we're going to create a new instance. And then we can continue, and now we have our second object. So that's basically how you set this project up. Now, right now we're only doing 32-bit versions, so let's go into our project and select all of our configurations and go into our configuration manager, and let's create a new solution platform. We're going to make this one 64-bit, and we're going to copy settings from Win32. There's only a couple of things we need to do in here. Inside of our 64-bit, we're going to add into our library path, because we added in that x64 folder. We're going to add an x64 inside of our library path. Copy it real quick, apply, and go into our general options, or our debugging options, and our command is going to be node root /x64/ configuration /node.exe out directory, apply, okay, and we run this. This is going to compile our project for 64-bit and run the 64-bit version of Node in debug mode. And now we have our add-on running under 64-bit mode. So the next thing that we want to do is actually save this as a template. So if we go into File, Export Template, we can choose Project Template, choose our Node add-on project, give it a template name. For icon image, if you go Browse, and then let's use our Node root directory here, go into, let's see, source, resource, there's that node icon image, and if you want, you can take some sort of preview snapshot of your code or what have you to have a preview for it. Now I already have one, so I'm going to just overwrite it, and now we can create a new project by coming in here and selecting Node add-on. We can create it, and just to show you, those debugging commands are going to default to target path and project directory, so we will want to change this to node home. We have our main and our my object in here as well. Now, I want to show you what happens if you run this without naming this the same thing as your add-on. If we require var addon equals require node addon, it's going to say it cannot find module node addon. Now that's not saying it can't actually find the add-on, it just means that in that gel file there's not that add-on named correctly. I'll come in here and say my first add-on and build it again, but it's probably going to stop our debugger. Go ahead and run it. Addon equals require my first add-on, and now we have access to that add-on, and we can create our my object again. So that is it for this tutorial, and in the future I may create more visual C++ Node tutorials. But that's the basics of how to get started wrapping C++ objects for Node.js.